Alright, so in this video we're going to get our dog up and running, following our cursor movement throughout the scene. So the first thing I'm going to do is I'm going to go into my sprites. I'm going to drag just this first dog 0 sprite into my hierarchy, and I'm going to change that sorting layer to player so that we can see it. He ends up being really tiny since he's a 16 by 16 doggo, so I'm going to make the scale 6 times larger. I'm just going to rename, since we're only going to have one dog in the scene, the sprite to dog. Next thing I'm going to do is I'm going to add a script to him so he can follow around my cursor when we hit play. So I'm going to go into the scripts folder and just create a C# script in there so I don't have to move it later. And I'll just call it dog controller. And I can go ahead and drag and drop that onto dog, so we see it there. So when we make changes to this guy, I'm going to double click so Visual Studio opens up, and when we make changes to the guy we can play and see in the it's already attached to the dog, so we can just go ahead and move it. So I'm going to make sure this is scrolled in large enough so that you can see it in the YouTube video. So I might scroll in and out, so beware of that. So in order to make this guy follow my cursor, what I can do is on update, I'm going to have a new vector 3, which is going to be, I'm just going to save my cursor position. So I'm going to call that vector 3 cursor camel case cursor position, and this is kind of a roundabout way to get the cursor position in world space, but the way to do it is you get your camera, and you get the main camera, so it's going to get the main camera in the scene. It's tagged as main camera, so that's how it finds it, and we're going to do screen to world point, and we're going to convert the input, the mouse position, and that'll convert that into screen space in the camera into world space in our scene. As I go about this, I'll make some comments about what I'm doing here. It's actually a good method to make the pseudocode before you make the code, so you know what you're doing. So I should have said something like grab cursor position in world space. And then here, the next thing I want to do is I want to have the transform.position update to the cursor position. So update dog's position to cursor location. And so I'm going to do that by getting my transform dot position. So transform grabs this transform here, this guy, and it's going to set that equal to the cursor position. If we save and we hit play and we're updating frame by frame our transform position, this should start to work. Let me see what's going on here. I want to maximize on play. Oh, I think what's happening is the Z position is being updated. So where is this guy actually? Where's my dog? Oh, he's... well, something's not right. He's not in the correct position. Okay, so actually I see what's happening here. So when we hit play, you can see that the Z position of our dog is at -10, and that's because it's going directly into where our camera is at -10, and you can see how I have the camera set up, like the field of view. It's orthographic, but anything within this huge O rectangular cube, whatever, the field of view is going to be shown in the scene, and because the cursor position is getting the position from this camera screen, it's actually pulling it outside of the field of view. So what I need to do is in the script, with this transform position, I can set this to a new vector 3, which is going to give me the cursor position. I want to save the X and Y position, but I don't want the Z. I want the Z to just be 0. So now we should be fine, and we should see the dog in the screen. Yep. So it goes around. The dog's not going to be outside of the arena here, so I don't really care if it shows above or below these guys. And soon we will make it so that it stays within the bounds. So the next thing, just a quick fix. It's nice to see the cursor disappear when we're playing the game, and the way we can do that is on start, when the level loads, we can say cursor.visible, excuse me, is false. And now when we hit play, the cursor disappears until we go outside of the screen. Now if we select outside of the screen and come back in, then it like reappears. So what I actually do is I move this line into update so that it's just constantly sending the it's constantly setting the cursor to be invisible. That way, even if we do something like move the dog, click out of the screen, and then come back, then it keeps disappearing. So that's kind of nice. And I will comment make the cursor invisible when playing. Okay, now to tackle the boundary here. So what I can do is I can have a couple empty objects to specify the corners of my rectangle. So if I create 2 empties, and I'm going to call this, well, we should be thoughtful about how, what corners we want to pick. So if this is 0, 0, then like a positive and positive corner versus a negative and negative corner seems to make sense to me. So I'm going to do a bottom left corner and a top right. And if we go to the scene view, make sure we're in 2D with these guys. I'm going to set Z to be 0. Actually, why don't I set both of these guys to 0, 0, 0 first. And if I hit W, we can see that it's in the center of the screen. Now I'm going to hold Control and move this shouldn't it snap to position? I guess it snaps to Yeah, why isn't the position snapping? Something's up with my shortcuts. Maybe it doesn't work with empty objects. Oh well. As long as I can move it into space, it should be fine. So this bottom left is going to be in the bottom left here to determine this boundary. I want to leave a little bit of space because the dog looks kind of weird if it's overlapping with the fence and it's going through it. So I make the boundary a little in from the fence. This bottom fence part not so much because it's okay as long as the dog doesn't go past the bottom part of the fence. So maybe we'll try negative 12. 12.25. Let's try that. And then a negative 3.75. Sure. We'll give that a go. And then on our top right, we can try maybe the same numbers will work. So on Y, 3.75 in the positive direction this time. And we'll say 12.25. Those look pretty decent. The nice thing about doing this method of having transforms instead of specifying in hard code in our script is that we can move this around and it will automatically make the boundary to whatever the location of these guys are, the way we're going to set it up. So we got these two guys, and what we're going to do is we're going to make a public transform object, which will be our bottom left corner. And if I do a comma, that's a shortcut way of specifying several different transforms. So I'll do the top right corner. Now in the inspector, we can specify two different transforms for our boundaries. And what we're going to do with those is before actually, oops, let me make sure that the comment goes with it. Clamp, we're going to comment, we're going to say clamp new dog position to the boundary. So we'll save two new floats for our X and our Y positions. The first one we'll call XPOS is equal to, and we're going to use the mathf library to get our clamp functionality. And what this is, if you look here, is that we can feed in a value and we can make sure we can also feed in a minimum and maximum so that it won't that value won't update to more or less than more than the max or less than the minimum. So we'll update this cursor position to, well, not update that cursor. We'll save a new X position which is going to feed in a cursor position. Cursor position dot x, and then our minimum is going to be our negative values, so our bottom left corner dot x, and our maximum will be the top right corner dot y. Oh, we need to get these are transforms, and we need to feed in the position to get the x value. So bottom left corner dot position dot x, top right corner dot position dot y. There we go. And I'm going to go ahead and highlight this, copy and paste, and that'll give us our y position. So we just need to update the cursor position, y, bottom left corner position y, and our top right corner position y. Oh, that was supposed to be x here. I don't know if I messed that up. I mean, I definitely did. Okay, so if I save this, go back into Unity. I'm just hitting Control S just so you know to save. You can also go over here and save all or save to the assets. Now I can feed into transforms. So my bottom left corner is called bottom left, top right corner is called top right, and yeah, those are correctly named. And when I hit play now, my dog, we got an error. Let's see. Oh, you know what? We didn't update. So in our script, instead of our transform position being our cursor position, now we're going to make it these X and Y positions that are clamped to the arena. So this guy is going to be our Y position. This will be our X position. X position. All right. Hit save again. When you hit Control S, you can see like the yellow changes that you made are turned green, and that's a good indicator that it's saved. If it's not saved, you'll have a little asterisk that says that like there are new changes. If you notice what I did there, enter asterisk. So if you want to know for sure that your changes have been saved, take a look at those two things. All right, now let's test it out. Alright, so dog does not go below this fence, and he doesn't go above here either. So he's locked in. Okay, so one thing I'm going to adjust, I think I can go down a little bit more with the Y. Maybe I'll go into 4.25. And this I can go up to 4.25. Let's see how that looks. Yeah, he looks like he's right in the middle, in the corner there. And yeah, he's not going past the fence here, so that's a good guesstimate. Cool, I like these values. Alright, so we have our dog. The dog position being updated to match the cursor position. We'll say that to next time. So for the next video, we will also put some animations onto our dog. So we'll do that in scripting, and we'll look at the animator to utilize some of these different animations here to update the animation on our dog sprite. Alrighty.